Hi everyone, in this video we are going to learn how to identify if a number is rational or irrational. So let's start with the definition of rational and irrational numbers. So real numbers are divided into two sets of numbers, and they're rational numbers and irrational numbers. So we can say that a real number is a rational number, either a rational number or an irrational number. So the numbers that can be written as m over n, where m is an integer and n is a non-zero integer, is called a rational number, okay? So we're going to give some examples. And what is irrational number? The number that cannot be written as m over n. So if we can write a number as m over n, or if we can write a number as a fraction, then we can say that this number is a rational number. If we cannot write that number as a fraction, then we can say it is an irrational number. So before we get to the examples, let's see some specific cases. For example, as you see, we have square root of 25 here. Since 25 is a perfect square, square root of 25 is going to be equal to 5, because we know that 5 squared is equal to 25. So that means square root of 25 is equal to 5. And we can write 5 as 5 over 1, because if you divide a number by 1, you get the same number. So that means square root of 25 can be written as 5 over 1, and 5 over 1 is a fraction. That means square root of 25 is a rational number. Why? Because square root of 25 can be written as 5 over 1. And as you see, we have another one. We have a repeating decimal, and repeating decimals are always rational numbers. Okay, let me explain why. I can write 4.5 and 5 keeps going on forever. As you see, there's a pattern here. 5 keeps going on forever. We can write this number as 4.555. Keeps going. So we can write this as a fraction. How can we do that? This is actually not the topic of this video, but we can write this as 45 minus 4 over 9, which is 41 over 9. So we can use our calculator to see if that's really correct or not. Okay, so let's divide 41 by 9. As you see, we get 4.5 and 5 keeps going on forever, which is 4.5, and we're going to put a bar above 5. So that means I can write 4.5 and 5 keeps going on as a fraction. That means this is a rational number. A rational number. So we can actually say all repeating decimals are rational numbers. Okay, so as you see, we have another number here, which is square root of 13. And as you see, the 13 is not a perfect square. 13 is not a perfect square. That means I cannot write root of 13 as a fraction. So if this number inside the square root sign, inside the radical sign, if this number is not a perfect square, then it is an irrational number. As you see, root 25 here is a rational number, but root 13 is an irrational number. All right, so let's do some examples. Okay, so we're gonna check all the statements that are true. So here it says square root of 36 is rational since 36 is a perfect square. Yes, that is correct. We can write square root of 36 as 6 because 6 squared is 36. And I can write 6 as 6 over 1. So that means square root of 36 can be written as a fraction. That means square root of 36 is a rational number. That means this is correct. And let's look at this. Since it is a repeating decimal, 3.2 is irrational. No, it is not correct. Let's remember, all the repeating decimals are rational numbers. Why? Because I can write 3.2 repeating as 32 minus 3 over 9, which is 29 over 9. So we can actually try. Let's get our calculator. So let's divide 29 by 9. As you see, it is 3.2 repeating. So I can write 3.2 repeating as a fraction, as you see. This is a fraction. So it is not correct. This is not correct. 3.2 is a rational number. All right, so since 10 is not a perfect square, root 10 is irrational. It is correct. It is correct. Because I cannot take 10 out here, okay? Because 10 is not a perfect square. Since it is a ratio of two integers, 11 over 13 is irrational. No, it is not correct. Irrational number means we cannot write the number as a fraction or as a ratio of two integers. Or if a number is a ratio of two integers, then that number is called a rational number. So this is not correct. Since it is a terminating decimal, 19.47 is rational. Okay, again, all terminating decimals are rational numbers, and all repeating decimals are also rational numbers. Because here I can write 19.47 as 1947 divided by 100. So I can write this as a fraction. That means this is a rational number. Okay, 19.47 is a rational number. It is correct. Again, terminating decimals are rational numbers. Repeating decimals are also rational numbers. Okay, so as you see, we have 3 true statements and 2 wrong statements here. All right, so let's look at these examples. Since it is a ratio of two integers, 2 over 6 is a rational number. That is correct. 2 over 6 is already in the form of a fraction, in the form of m over n. So it is a rational number. Since it is a terminating decimal, 14.9 is irrational. No, it is not correct because 14.9 can be written as a fraction because it is 149 over 10. And if you can write a number as a fraction, that is a rational number. So this is not correct because this is an irrational, rational number. Let me write it. Is a rational number. Since 3 is not a perfect square, root 3 is irrational. Root 3 is irrational. Let's remember, if this number is a perfect square, then that is a rational number, but it is not a perfect square. Root 3 is actually a number between 1 and 2, but it is a decimal, but it is non-repeating and it is non-terminating. Okay, there is no pattern after the decimal point, and we cannot write root 3 as a fraction. So that means root 3 is irrational, so it is false. Since 81 is a perfect square, root 81 is rational. Root 81, we can write root 81 as 9, and we can write 9 as 9 over 1. That means root 81 can be written as 9 over 1, which is a fraction. That means root 81 is a rational number. It is true. Since it is an integer, 4 is irrational. So I can write all the integers as a fraction. I can write 4 as 4 over 1. Okay? Because if you divide a number by 1, you get the same number. So 4 is equal to 4 over 1. That means 4 is rational, because I can write 4 as a fraction. If you can write a number as a fraction, it is a rational number. If you cannot write a number as a fraction, it is irrational number. So this is not true. This is false.